Hello students, welcome to the course on Advanced Communication Systems and the course code is EC801. This is a 3 credit course and it is for BTech 8th semester EC students. Myself, Dr. Shurojit Boshak, Assistant Professor of EC Department, Guru Nanak Institute of Technology, Kolkata. And this is my official email address. In the last class, we have discussed about cumulative distribution function CDF, probability density function, and also solved some numerical problems. Today, we are going to discuss about the different types of probability models from the module number 1, that is probability theory. And the lesson objective of this topic is, upon completion of this lesson, students will able to explain the concept of probability, calculate the probability of simple events, calculate the probability of compound events, calculate the probability of complementary events. And this topic is mapped with CO number 2. So let us start lecture number 4 from the module 1, that is probability theory, with the topic of different types of probability models. In the communication field, we come across various types of random variables. They will have their own probability density functions which are different from each other. Practically, it is very difficult to study all these probability distribution functions. Hence, the PDFs of all the random variables are approximated to some standard probability density functions. Such commonly used standard PDFs are binomial distribution, Poisson distribution, Gaussian distribution, Rayleigh distribution, and uniform distribution. Out of these 5, the first 2, that is binomial and Poisson distributions, are used for the discrete random variables, whereas the other 3, that is Gaussian distribution, Rayleigh, and uniform distributions, are used for the continuous random variable. So let us first start from binomial distribution. Binomial distribution is used to describe an integer valued random variable associated with repeated trials of an experiment. Binomial distribution can be applied to digital communication systems. For example, to find the number of errors in the message signal of n digits. To understand the binomial distribution, let us consider an example. Let us assume that binary words, each of length n, are being transmitted. Now, out of these n bits, let x be the number of success, number of correctly desired bit, and n minus x bits are in error. Let probability of correct reception of a bit is P, and the probability of error in reception of A bit is Q, and Q is basically 1 minus P. Therefore, the PDF of random variable say X is NCX, that is a combination, into, this is the probability of getting a success in a trial. And the total number of success is X. So now it is P to the power X, and Q is the probability of failure in one trial, and N minus X is the total number of trial for failure. So it is Q to the power N minus X. So that means it's basically factorial N by factorial N minus X into factorial X, P to the power X into Q to the power N minus X. Next is the Poisson distribution. This is another standard probability distribution used for the discrete random variables. And the PDF of Poisson distribution is lambda to the power X into e to the power minus lambda by factorial X, while lambda is basically the mean value, mean number of occurrence in the interval. Okay, and X is the random variable. Next is, okay, suppose an example is present here following Poisson distribution. Suppose 10,000 digits are transmitted over a noisy transmission channel having error probability per digit equal to 5 into 10 to the power minus 5. Estimate the probability of getting 2 digits in error. Use the Poisson distribution. So, probability of X equal to K, that is basically, we know that lambda to the power K. Now, lambda is the mean value, which is basically N into P, where N is the number of digits and P is the probability of error per digit. And K is, so it is now NP to the power K into e to the power minus NP by factorial K, where K is the number of digits in error. Now we know that the total number of digits is 10,000 and probability of error per digit, that is P, is equal to 5 into 10 to the power minus 5, and probability of 2 digit, getting a 2 digits in error. So K is 2. So we put all the values and the result will be 0.0752. Okay. Next is very important distribution, which is called Gaussian distribution, or it is called normal distribution. The Gaussian distribution is used for continuous random variable. It is perhaps the most important PDF in the area of communication. The majority of noise processes observed in practice are Gaussian, and many naturally occurring experiments are characterized by continuous random variables with Gaussian PDF. The PDF of a continuous random variable having Gaussian distribution is given by fx is 1 by sigma into square root of 2 pi into e to the power minus x minus mu whole square by 2 sigma square, where mu is basically the mean of the random variable and sigma square is the variance of the random variable. Gaussian PDF is also known as normal PDF. The shape of the Gaussian PDF is like a bell shape, which is shown in the figure. Now, if I want to calculate the CDF of Gaussian distribution, then the CDF, from the definition we know that the CDF is basically minus infinity to x into PDF, that is fxx dx. Now substituting the PDF value from here to put in this expression. So the CDF is now integrating minus infinity to x 1 by 2 pi sigma square e to the power minus x minus m. M is here the mean value whole square by 2 sigma square dx. Now how to solve this problem? Easy way, just consider x minus m by sigma square root is y. Now find out dx dy and change the limit. So after changing this limit, it now becomes basically this integration. So ultimately, it is actually form a ERFC function. We know it, it's basically an ERFC means complementary error function. So it is now the CDF of Gaussian distribution is now half ERFC m minus x by sigma into square root. This is the required expression for the CDF. The complementary error function is a monotonically decreasing function. Hence, with the increase in the value, that is m minus x by sigma into square root, that is the argument, the value of the complementary error function goes on decreasing. Okay. Next is Rayleigh distribution. Now, it is also used in continuous random variable. The PDF of Rayleigh distribution, which is represented as fx sigma, x is the random variable and sigma is the standard deviation. This is now x by sigma square e to the power minus x square by 2 sigma square when x greater than or is equal to 0. Now, if x less than 0, the PDF now becomes 0. So, if we want to find out CDF, that is simply integration. So after integrating it, it now becomes 1 minus e to the power minus x square by 2 sigma square. Whereas it is its mean and variance is sigma square 4 minus pi by 2. Now, if we plot the PDF, it now shown here for different values of sigma. The first case, this is for sigma equal to 0.5. Now this blue is the sigma is equal to 1. This is for sigma equal to 2. This curve is for sigma equal to 3, and this is for sigma equal to 4. So whenever we increase the sigma value, the height is reduced and width becomes wider. Okay. Next is another distribution, which is uniform distribution. If a continuous random variable x is equally likely to be observed in a finite range and is likely to have a zero value outside this finite range, then the random variable is said to have a uniform distribution. The PDF of uniform distribution is shown here. The PDF of a random variable having a uniform PDF is given by fx equal to 1 by b minus a for x in between a to b and for a greater than 0. Otherwise, it is 0. Okay. And it has a mean value of a plus b by 2 and variance b minus a whole square by 12. So that's all about distributions. Now I am here, it is a numerical problems based on CDF. A certain random variable has the CDF given by fx is 0 for x less than equal to 0, k x square when x in between 0 to 10, and 100k for when x greater than 10. Now calculate the value of k, find the values of probability of x less than equal to 5 and probability of x in between 5 and 7, and plot the corresponding PDF. So how to solve the problem? First of all, we know that this 100k should be 1 because it's now once for x greater than 10. So 100k is 1, and following this we know that k equal to 0.01. Now next is we have to find probability of x when less than equal to 5. So it is basically x in between 0 to 5. So that is basically CDF of 5 minus CDF of 0. Now what is CDF of 5? That is kx square, because 5 in this range. So kx square, and CDF of 0 is 0. So put the value of k and x and we get it is now 0.25. Now similarly, when x in between, probability of x in between 5 to 7, it's basically CDF of 7 minus CDF of 5. So that is kx square for x equal to 7 and kx square minus kx square for x equal to 5. By putting this, we are getting the value that is 0.25. And lastly, PDF. PDF basically the differentiation of CDF. So only see the problem, only kx square, this has a x term, but x less than equal to 0, that is this, and 100k have a PDF of 0 because there is no x term. So only there is a PDF present in this for this term, that is kx square. So we have to differentiate it, that is 2kx, and put the value of k, that is 0.01. So PDF is 0.02 into x. Now we are plotting here for the PDF with different values of x. First, for 5, x equal to 5, it is now 0.1, and for x equal to 10, it is now 0.2. Okay, so this is the PDF plot. Okay, that's all. Thank you.